In this lesson, we're going to simplify simple expressions using the distributive property and combining like terms. So the first type of examples we're going to look at are simplifying by using the distributive property. So this first example here, I have 3 times x plus 2. So I'm going to distribute the 3 by multiplying it by the x and the 2. So 3 times x is 3x. Plus 3 times 2 is 6. In the next example, we're going to multiply negative 6 times x minus 2. Negative 6 times x is negative 6x. Negative 6 times negative 2 is a positive 12 because we know two numbers that are negative multiplied together will equal a positive number. Our next example, we have negative, then x plus 7. So if this confuses you, you could always put a 1 in front and think of it as multiplying by negative 1. Negative 1 times x is a negative x or a negative 1x. Negative 1 times positive 7 is a negative 7. Our last example has one more step of complexity to it. We have x minus y plus 4. Now notice here we are not multiplying by the x. What we're doing is we're multiplying by the negative 1 first because we know we multiply before we subtract, and then we will do subtraction if we need to. So negative 1 times y is negative y. Negative 1 times positive 4 is a negative 4, and this x out here just comes on down. Nothing needs to be combined, so this is a simplified expression, x minus y minus 4. Our next set of examples are simplifying by combining like terms. So here, remember a like term is a term that has the same variable with the same exponent. So constant terms, which are just numbers, they're like terms. Terms that have just a single variable that is the same, such as this first example, negative 3x plus 5x, those are like terms. So I can combine them by adding the coefficients together. Negative 3 plus 5 is 2 x's. And x's that have the same exponent, or y's, or any variable that has the same exponent are considered like terms. So here I have 3x squared plus 15x squared minus 4x squared. So I have 3 plus 15 is 18, minus 4 is 14, x squared. Notice how the variable and the exponent don't change here. It's like we're counting how many of that particular variable we have. So you may have heard in the past them say, don't think of it as an x, think of it as an apple, or think of it as a car. Think about what you are counting here. That's what the coefficient stands for. It stands for how many of that item we have. In the next example below, we have multiple different types of terms here. So I have 2 plus x minus 6 plus 5x. Normally we write our expressions in descending order by the exponent. So here I'm going to start with my variable x. X plus 5x gives me 6x. Remember, the sign is always attached to the number behind it. So next, my like terms are 2 minus 6, which is a minus 4. So 6x minus 4 is my simplified expression. Those terms cannot combine because they are not like terms. Last example, I have 1 plus 4x plus 5x squared plus 2x minus x squared plus 2. Again, we're going to try to write it in descending order by the exponent. So I'm going to start with the x squared terms. 5x squared minus x squared is 4x squared. Next, we have x terms. 4x plus 2x is a 6x. Lastly, we have our constant terms. 1 plus 2 is 3. And all of those expressions are as simplified as they can be. Now let's look at some more complex expressions. So here I have 5 times x plus 2 plus 4 times 6 minus x. The first thing that I want to do, again, remember our order of operations. We start with parentheses. X plus 2 and 6 minus x. They can't be simplified any further, so I can move on to the next operation. Exponents, there are no exponents here, so we don't have to worry about that. Next is multiplication and division from left to right. I don't have any division, but I do have some multiplication, so let's handle the multiplication. I have 5 times x plus 2, so I'm going to distribute the 5, and I get 5x plus 10. I also have another set of multiplication here, 4 times 6 times 4 times negative x, 24 minus 4x. Now that I've distributed everything, I can then move on to addition and subtraction, which would be my combining like terms. 5x minus 4x is x. 10 plus 24 is 34. Our next example, I have 7 minus 2 times 5x minus 3. Again, I'm going to do my multiplication first. So 7 minus 10x plus 6. Now let's combine like terms. Negative 10x plus 13. Last example here, I'm going to do my multiplication first. 32 minus 8x minus x plus 5. Negative 9x plus 37. Our last set of examples that we're going to look at involve fractions. So here I have 5x over negative 3x. Remember, when we have fractions, we can simplify by canceling what's in common in the top and the bottom. So the first thing I see that we have in common are the x's. Once I simplify those, I have 5 over negative 3. That doesn't simplify any further, so I would leave it just like that. We want to get in the habit of not writing mixed numbers and not writing repeating decimals. Just leave everything as a reduced fraction. It saves you time, it saves you work to do, and that's normally how you're going to see your numbers in upper level math classes. This next example is slightly different because, as you can see, I have multiple terms in that numerator. So what I can do is split up the fraction. 12x over 4 minus 8 over 4. And now this looks similar to the first example. 12x over 4, well, 12 divided by 4 I know is 3. The x doesn't change, so it stays there. Minus 8 divided by 4 we know is 2. So 3x minus 2 is my simplified expression. Our last example here is the same idea. 6x over negative 3 minus 3 over negative 3. 6x over negative 3 is a negative 2x. Negative 3 over negative 3, well, that's just a positive 1.